Welcome, everybody. Thank you for joining today's webinar. We're going to be talking about how AI is changing the offensive security landscape. With me today, I'm Paul Mote. I'm the Vice President of Worldwide Architects for Synack. I'm joined by Dr. Mark Core, co-founder and Chief Technology Officer of Synack, as well as Brandon Torrio, who is our Senior Product Manager, as well as a up-and-coming rock star.
Thank you. I'm actually just here to promote the album.
Thanks for the introduction, Paul. Good to be here.
So we have a lot to talk about today. Obviously, we want to show the product as well. I think what's interesting is there's a huge change in the overall landscape. We're hearing all these trends about AI-driven attacks, AI-driven exploits, lots of noise in customer environments. They're having a really hard time figuring out what to ultimately take action on. Mark, you've been in this space a long time, both as an operator, as a builder. You kind of been on the forward-leaning side of things in terms of talking about how the landscape is changing. What does this all mean? What's the real takeaway in terms of where the industry is going and where we have to go together?
Well, I mean, what we saw last year is we reached new heights for the number of vulnerabilities that were assigned a CVE. About 40,000 different vulnerabilities assigned a CVE. And now that artificial intelligence is being used for everything from reverse engineering to malware weaponization to discovering new vulnerabilities, we're going to see that number go far, far up. It's going to be closer to 100,000, before we know it. And one of the things that we're noticing is that adversaries are moving beyond simple automation and instead incorporating, AI-powered attack chains into their malware products, into their propagation mechanisms, into their avenues of selecting targets. And what we're seeing is the newly introduced vulnerabilities are actually exploited very, very quickly. It's coming down to hours and minutes, where you used to have a vuln management program that would strive for fixing vulnerabilities in a week or two for criticals. That needs to be down to hours and minutes. So we really need to introduce artificial intelligence for defenders that can detect those vulnerabilities that are exploitable, so they can be resourced for mitigation or remediation quickly. It's really, still the same game of security fatigue as well. Lots of alerts, lots of meaningless alerts, and it leads to this alert fatigue where we're seeing, people not on the security defense side, not ready not really sure how do I address all of these holes that I have. And so we see a place where artificial intelligence can be used in an agentic sense to start to assess lots of things in parallel. And we're going to show you some of that today in our product for Sara Triage, where agentic solutions can be used to accelerate the time to identify vulnerabilities that are exploitable and really help you resource quickly those issues that could lead to a breach. The ultimate goal here is to prevent a breach. That's what we're doing every day around here at Synack, and that's what most security practitioners do in the field is just try to stay ahead of the bad guys.
Yeah, it's unprecedented year so far, right? In terms of hearing about vulnerabilities hitting the news within hours, being weaponized, scanning across the internet, and if you don't know what's there, you're not taking action on it right away. You end up on a list, having to spend all this money in IR and bring down operations, and it's really making the opportunistic attacker far more successful than they've ever been before.
Yeah, I mean, it's really adding a lot of complexity to it because, as AI capabilities are introduced to, malware, for example, you're ending up with polymorphic malware that's never been identified, and AI is rewriting, the malware on the fly post-infection. Google just came out with a threat research report on this. Super interesting application of AI, but also quite scary if you're trying to, mitigate that threat.
Yeah, absolutely. Yeah, I even saw some of the AI services being used for C2 traffic, which reminded me of like how Twitter was abused back in the early 2000s. So it's what's old is new again. It's just new flavor.
It's another covert channel. That's right. It's just it's new ways of taking advantage of popular techniques and software.
I've always thought of finding risk proactively and being able to identify things and measure programs about some of the traditional methods, right? Kind of doing pen testing. Obviously, we got a change in the way the landscape is playing out. And so we have the traditional pen testing, PTaaS, Agentic-AI. How are folks supposed to think about and position these different offerings in your mind, Mark?
Well, I think traditional pen testing. Let's start there. It's an approach that does work. We know it works, but it has capacity constraints, right? And so you're seeing a lot of offshoring to get more capacity because we don't have enough folks either domestically or in Western Europe. And so you're seeing a lot of offshoring to get that elastic capacity so we can get more resources at finding these vulnerabilities. The reality is our attack surface has grown dramatically. And we need a new approach. And that's where, pen test as a service, companies come in to differentiate instead of, a traditional pen testing approach where a consultant is assigned and they do 40 or 80 hours of fixed time. PTaaS offerings can be more continuous. They involve a freelance community of researchers and it can be applied at a greater scale with more elastic workforce. In addition, software to manage the continuous testing programs, which is a key element to staying ahead of the bad guys. And where Agentic comes in is starting to automate, some of those, some of those processes that were happening with people. And Agentic AI can really take on some of that, assessment of a vulnerability, some of that, research on is this exploitable or not, and start to report back quicker than having a human in the loop. And so we're really focused on the agentic solutions, making us faster and getting us to a place where the mean time to remediate is starting to go down. Unfortunately, we're going to have to combine, what AI can do and what people can do, and really make these systems work well together, recognizing that AI is not going to replace people anytime soon. But agentic solutions can make people more effective, and it can bring us to the places in our infrastructure that really need attention quickly.
Yeah, and that's one of the exciting things I've seen about this year in terms of our developments and how we've started to look at the space and integrate with our customers, get their feedback, build it out, which kind of speaks to something you've said for a while. Ever since the original AI components came out years ago, that actually seemed like they were going to be worth something. I remember you mentioning it's got to be an agent and human process that comes together, right? And goes back to some of your original messaging. I won't steal the thunder there, but I love the idea of fusing human and automation together in a way that's a lot smarter. And so early this year, we announced the Synack autonomous red agent, Sara. And obviously, we launched the triage piece of it earlier this year, where we're integrating, pulling in customer vulnerabilities and giving some signal inside that big pile of noise, because the vuln stacks for customers they're massive. They have no idea how to get through that. And so providing some level of fidelity there is really important in this time. And of course, we're launching Sara Pentest, which is part of the major announcement for today. Yeah. We're really trying to cover more at scale. But how do you view the importance of the human in this process? Because I've heard a lot of different things in terms of how people position the level of trust in AI and AI autonomy, if you will.
Yeah, I mean, we've been doing this for about a decade now. We really started with a tagline at Synack of man and machine, recognizing that humans are going to start a pen test by running some automated scans to find low-hanging fruit vulnerabilities, and really, use tools where applicable. It doesn't make sense to do everything manually, of course. And where Agentic is going to really transform that is add another layer of analysis on top of those automated tools. And those automated tools have gotten really good, but what's interesting about Agentic is it can take the outputs of multiple tools and push that even further and start investigating whether those tools are actually generating results that are accurate, and then start to push that forward to determine exploitability. Our goal is to really give more signal than noise, and part of that is giving the defending teams accurate data on which vulnerabilities are actually exploitable, so that they can focus there first. But AI systems are new. There's a lot of new things, that may not give the quality that we want. And so humans in the loop are super important, as these AI systems are so early. They do hallucinate. They can go off the rails a bit. And so, it's really important for a human to be in the loop and review those outputs. So what we've done is added a human in the loop review for all agentic vulnerabilities that are discovered, so that we can determine whether they're actually accurate or not. What we're seeing, though, is it's fairly accurate. We have multiple agents doing validations as well. So agents grading agents. It's really cool to see. But it runs through the second level triage, the second level QA with another agent. It's super cool. But yeah, at the end of the day, we want a human to review those findings and make sure it's actually really accurate. And I think this is really important as these AI systems are developed. So where we're taking Synack Autonomous Red Agent is to move fast, go find as many exploitable vulnerabilities as possible, raise that for human review. If you can take take that process and make it continuous across all your assessments, think of the speed you're adding to that detection lifecycle, right? We're really seeing AI as a co equal partner in the team, right? We want that AI agent to automate things that were taking human time, so we can release humans to work on creative problems, harder problems that AI can't solve. And that's really where we see the human analyst evolving, is really focusing on the problems that require human creativity and that human knowledge that comes from experience.
Yeah. Speaking of the use cases, because I think you've covered quite a bit there, Mark. A question that I had for you early on, right? I've heard there's this thing called autonomous pen testing, and it's been around for like 10 years. And for whatever reason, it doesn't seem like it fits the bill. I assume that's why Sara Pentest came about, but why create Sara Pentest?
Yeah. So
it's already
the
covered.
words get confusing here, Paul, and I think, folks like Gartner do add a lot of new words to label new workflows. And, we had, vulnerability assessment, which is really scanning, going after and finding as many vulns as possible that matched a fingerprint. Then, automated pen test came in, which is really another name for automated scanning. But where agentic comes in is it pushes it even further and says, all right, well, I see what you've detected this with a fingerprint, but can I go further and actually, throw an exploit to actually prove that this is exploitable? And that's really our focus with Sara Pentest. We wanted to take that extra step that the automated systems are not taking, and do this safely, right? That's the other important bit. So, to be an enterprise class capability that can be deployed across sensitive assets and do these checks in a safe manner. But really what separates, the Synack Sara Pentest from anything else on the market is really that focus on determining exploitability. And then the human in the loop to make sure that it's accurate. So we're really seeing that as a differentiator in the space. And it really helps people, who are dealing with a lot of scanner findings they just don't have time to go through. But it's an evolving space, and we see this as a critical component to combating adversaries using AI for offensive purposes. We've got to take the speed of review down to minutes, and alerting to remediation systems and follow-on mitigation systems.
Yeah, which I think speaks to some of these use cases that you've outlined here before, right? In terms of, because I've heard about you talking about these in the news, right? Making sure that window of exposure of what's out there, it's got to shrink, otherwise you're hosed. Making sure that you've got all the data in one place, that way you can make strategic decisions, because believe it or not, people still stovepipe different types of data in different places, and it really dramatically reduces their tactical efficacy in terms of what they're trying to do. And so I love that positioning. Let's talk about the flow of Sara Pentest, because I know people are trying to think like, what does an actual pen test look like, which I know is challenging. So we have a visual to kind of walk through some of it. Walk us through how you view the execution of a Sara Pentest with this diagram.
So what we've done is we've designed Sara Pentest to operate just like a human operator. So it starts with intelligent reconnaissance, and then it leads right into attack planning and prioritization. So what we're giving it is a full attack surface map. We want it to enumerate the common ports, the services that are there, and start using that to determine which tools it should use to probe for vulnerabilities. In addition, it can take in existing vulnerabilities that have been, already identified from scanners that you've run. So those can be fed in, but the goal is to give that agent as much context on the environment, on the target as possible. And then it fans out. It starts to fan out into specialized agents for what it finds. And each specialized agent is purpose built to find vulnerabilities in a specific technology stack. So, or of a specific vulnerability category. So for example, we may have an agent on SSH to look at all your SSH services. We may have an agent for cross-site scripting that can start probing your web applications for cross-site scripting vulnerabilities. And even beyond that, there'll be sub-agents for the different types of cross-site scripting vulnerabilities. And then all of those things are working in parallel. They're going, and at the end of that flow, they report all their findings up to the centralized, Synack vulnerability management system. And so you start to see that those results stream in over time. And it becomes really this this team that's always working for you. It's always out there. It's always hunting, and it becomes your partner in crime as to like, this is the team I wish I had. This is the team that's always awake. When my team's asleep, they're looking. And so these agents are going to be running around the infrastructure trying to find vulnerabilities that are exploitable, and then reporting that to you as fast as possible, but not until we do a human in the loop verification. So it's really a combination system of agents and humans working together to give you that real time intelligence.
I want to double click into something you said there too, Mark. You mentioned the specialist agents, right? I've heard a lot of people generalize agentic capabilities and be able to say like you can just throw some pretty broad parameters at it and it comes out with magical things. It kind of sounds like you're saying the opposite of that. And so what is the dependency there? Why have specialist agents?
The specialist agents, you're right. You can ask a model generically, go hunt for cross-site scripting vulnerabilities, but where ours are different is we're starting to hand it specific techniques and tactics that we've seen successful in the wild in the last decade of doing this business in pen testing. And you're seeing like, unique payloads, creative approaches. In addition, starting to identify that recon information that led to that identification of a page that might have an issue. This is where most scanners are missing the mark. They're just throwing the same stuff at every page and going. And these agents are more intelligent based upon the experience that we have, and the experience comes from doing this pen testing business for a really long time.
Yeah, it does require a lot of insight across the large attack surface in order to really tune those things properly. Well, I think the next step here, what we'll do is we'll pivot into a live demo. And Brandon, I'm going to hand this over to you.
Cool. Thanks, Paul. So yeah, I'm going to pop up the Synack platform here and actually walk through what it looks like creating a Sara Pentest in the platform. We start here at the asset level here, and we have a discovery capability built into the Synack platform here. So what you can do is create a seed group. Typically, I show people that you can discover some assets here by giving a seed group name. You can define access, enter a seed, and you can run discovery just like this. That gives you a asset list, which is populated with the assets that we discover in the platform. So we've made an effort to make asset management in the Synack platform very easy and also powerful, so that as you do activity in the platform, as you do things like import vulns from a source like Tenable or Qualys, and you do lots of testing activity, you can quickly sort by things that have the most suspected vulns or things that were most recently tested, or you can sort by things that were recently tested or things that haven't been tested in a long time. So for this demo, I'm just going to grab the acme.com asset that I created and do create test. And here we have a pretty self-explanatory menu of the testing options we have. We have our core human-driven open vulnerability discovery engagements here below, like our 14-day pen test or our crown jewel offering, the Synack 365 year-round pen test. At the top of it for this demo, I'll select the Synack Autonomous Red Agent Sara pen test here. So you can select that, continue on, and then you provide some simple information about what the group of assets is to you. So maybe this is your main customer-facing retail website. Give us information about it, articulate the scope. You can add tags to it. You can add an owner to it so that we know who to contact about the test. Different things like that over the years of pen testing through the Synack platform, we've identified are useful for test management and test creation. Give the test a name. So maybe this is your monthly or quarterly compliance test. Again, specify information about the scope. Enter the start date you want, outage windows when you want the testing to pause, more information about people who should receive a notification when the testing begins via email, or you can add them to the platform. We have here a pretty cool feature, a asset reachability scan powered by AI to tell you whether or not we can see your assets properly from the Synack platform and kind of give you an idea of the access across the maybe 250 hosts you provided, how many of them are actually up and responding. Pretty useful tool for people as they schedule their own tests. And then you can go ahead and submit it. And it's as simple as that. After it's submitted, the Sara Pentest will go live, and you can go into that group of assets, in this example, the Acme web assets, and maybe you have many tests here, maybe you have it adjacent to some of the open vulnerability discovery pen test with humans, but the Sara Pentest will be there. It'll be marked as completed after the test is finished, and you'll have a viewable report here. And so in just a second, Mark, I'll pass it over to you to talk more about what is the agent actually doing during the test. But the net of the test management flow is what I just showed, and it results in a nice viewable report here that contains an executive summary, details about when the test was performed, the scope over which it was performed, and of course, any vulnerabilities that Sara found during the pen test. So with that, I'll stop sharing and pass it back to you, Mark.
Hey, thanks, Brandon. That's really great. I'm going to jump in and show a little more detailed demo. The Sara pen test is intended to be a very good compliance pen test. So if you want to just run a test that covers, like on web, the OWASP top 10, it's a great product for that run quickly. We also offer a variety of human tests that may go into more depth. But the Sara pen test initially that we're launching is a great fit for your compliance pen testing, and identifies surface level risks that may exist. So I'm going to show you a little bit about what happens during the pen test. Let's look at one of the agents. So let's say during the pen test we're running scanning. Those scanner findings could come in as well as part of that pen test. And let's look at what the agent would do on some of these scanner findings. In the context of a pen test, this would just happen automatically, but I'm going to show you a discrete action of one vulnerability that it's identified. And this would happen automatically, but we have a UI if you want to do it one-off as well. So in this case, the vulnerability was discovered was a OpenBSD, OpenSSH issue. It was identified by a couple of CVEs. We can go ahead and submit that for Sara Triage. So let's do that here. And what's happening behind the scenes is this vulnerability information is being assessed by the agent. It's spinning up those specialized agent vulnerability hunting subsystems that we talked about, and those sub-agents are going off to prosecute this vulnerability and see if it's actually vulnerable. And if it's accurate, it'll determine if it's exploitable as well. All right, here we go. The agent thinking's already popping in. So it's gotten the initial information and it's starting to talk to the machine. It's got some tools here. It looks like it's got an exploit from a nuclei template, and it's going to attempt to run that against the target. It's going to start connecting to the server, examining the key exchange algorithms that are relevant for this Terrapin attack. And then it's going to, as a next step, throw that attack safely at the end target. In a Sara pen test, this all happens at the same time behind the scenes with many agents, and you view the end result in the report that Brandon highlighted. But if there was actually a vulnerability that was exploitable, you'd have that showing up under the vulnerabilities tab here in the platform too. We're waiting for the agent to do its work. This typically takes about 3 minutes. Looks like Sara's finished its thinking and determined that this vulnerability is not exploitable, which is good. So it's going to save us a lot of time on remediation, because Sara's already taken a look at this vulnerability and said, hey, based on my recon and my assessment with a variety of tools, it's not vulnerable to this CVE, and we can move on. So it's already closed it as not exploitable. This is a good outcome. Now, I think we should do one more look under the hood, perhaps. What do you think, Paul?
What are we looking at here whenever we're looking at the walkthrough of this pen test engagement?
Yeah, so one of the things we wanted to show here, it was great fun showing, the agent exploit a CVE, but thought it would be fun to kind of show a web application in the context of a lab environment, and show the agent exploit that lab environment and find a vulnerability in there. So one of the things that the agent can do with web applications is authenticate to them, and then start to crawl the pages and fuzz and look for injection points. And so that's what we're seeing in this example. It's starting to crawl this sample app here and look for potential vulnerabilities. In this case, one of the more complicated vulnerabilities is a blind SQL injection, where it's a timing related issue. And so we're going to see the agent prosecute this target and run through a series of queries and see if it can spot the timing issues in the requests.
It's interesting. I see right here that we've already completed the recon phase against it. We're starting to select various tooling and modifying what tools we plan to use based upon what we saw in recon.
That's right. Yeah. So we're past that recon phase. Now we're selecting our toolkit. We're moving into the specialized attack section of the agent workflow, and it's starting to spin up in parallel a bunch of different tasks to start to prosecute that target. Next up, we're going to see it attempt a bunch of requests and start to see what looks normal and what looks abnormal. And a lot of the behaviors that we are expecting the agent to identify are things that we train pen testers on. So we're training these agents very similar to how we train a human pen tester. If we were training them to become a specialist at spotting these types of vulnerabilities, and the agents are getting quite good at these things. While this is a somewhat trivialized example for the purpose of a demo, testing these in the wild, it's finding a lot of vulnerabilities that would have taken humans quite a long time to find. And some of our advanced pen testers have been running the agents side by side, and they're finding it's super helpful at finding things faster than them. And just one example, one of our pen testers was saying, this probably would take me 4 or 5 hours. The agent did it in about 20 minutes. So it's a pretty great time savings, especially if you think about you're also offloading that work to the agent and letting it do its thing. So you could run many of these at the same time, and that's exactly what Sara Pentest does during its workflow. Is it's prosecuting that target in parallel with a bunch of different tools and a bunch of different specialized agents, and then yielding results at the end.
Yeah, you can see all the different sub agents kicking off, running tools, getting feedback, feeding it back in, running the next series of tools based upon kind of trial and error.
Let's skip forward to the end and see how it performs. See if it solved the lab.
All right, we've been letting the pen test run for quite a bit of time. I think we're nearing the end of the execution cycle of it. Let's see what it ultimately turns out to be, or what the outcome is after it's run against this web app for a while. It looks like it's running its final task. It's trying to build out its final report.
It solved the lab. Look at that.
It did solve the lab. Not only that, if I'm reading this correctly, the blind SQL injection was successful. It was able to extract the administrator username and password. Is that accurate statement there, Mark?
Yep. Full compromise right there.
That's very promising. It's going to be very interesting to see this deployed at scale across customer environments to look for those vulnerabilities.
Absolutely. Really powerful companion in the security testing process.
Well, that was really exciting to see the pen test go from start to finish and see kind of some of the underlying sub-agent workflows. We hope this has been a really insightful session. Thank you again, Mark. Thank you again, Brandon, for spending the time today and helping educate our customer base. If you want to learn more about Synack's Agentic-AI, just make sure you can reach out to us. It's hpsgo.synack.com/demo. There's a form to fill out. Ultimately, you can engage with us, and we're happy to hear what your use cases are and see how it fits in your portfolio. Thank you all.